All right, y'all. Let's get started on this. So this question is pretty straightforward. This says create a scaled copy of a triangle using a scale factor of 2. And so basically we're going to take this original and then we're going to make a copy. And so in order to get this, we need to multiply our first triangle by a scale factor of 2. And so I would need to multiply each of the corresponding side lengths by 2. So I would do 8 times 2, 4 times 2, and then finally 7 times 2. 8 times 2 would give me 16 centimeters. 4 times 2 would give me 8 centimeters. And then finally 7 times 2 would be 14 centimeters. And so then when I make this triangle, right, I would have a side length, right? 8 times 2 is 16 centimeters. Here, we would have this side length here. 7 times 2 is 14 centimeters. And then finally, I connect them up top. 4 times 2 is 8. So this would be 8 centimeters. Boom. And then something that we do know is that angles do not change. So these angles remain the same. We don't want to touch these. And so we have 90 and then 30 degrees. And so basically these angles do not change. So did the angles get scaled or changed? The answer here is no, right? They did not. And then finally, are the corresponding sides twice the size? Well, 8 times 2 is 16, right? All the sides are twice. All the corresponding sides are twice the size. And then finally, is your area of your copy twice the size? Well, this has an area of 14 centimeters squared, right? 7 times 4 is 28. 28 divided by 2 is 14. And then finally, this one here would have an area of 56 centimeters squared, right? And we can see 14 times 2 is not 56. So the area was not scaled by 2. So we put no there. The area was actually scaled by 4. And that was our first question, which this will be a multiple choice one on your test. You guys got it. All right, now we go here. Here, this says a rectangle measures 10 inches by 5 inches. Rectangle X is a scaled copy of the rectangle. Select all the following pairs that could represent the dimensions of rectangle X. So if I have my original rectangle here of my 10 inches by 5 inches, right? So this is our original. And then I have a bunch of other options, right? I could say that 2.5 by 5, that's one option. 3 by 6 is another option. Again, these are all just inches. I could have 7.5 by 10, by 15. So 7.5 by 15, right? We have all these rectangles. Here I could do 3.5 by 8, and then 20 by 10. Right? And we want to know, are these copies of our original? And so what I can do is I can set up ratios, right, of my copy over my original, like so. And so here I can do my width and my length. These are my two ratios. And so finally I can set this up, right? 2.5 over 5. Is that equivalent to 5 over 10? Well, 5 times 2 is 10. 2.5 times 2 is 5. So these are both multiplied by 2. As a result, this one is a scaled copy. I can do that again with our next one, right? So I set it up as 3 over 5. 3 over 5. Is that equal to 6 over 10? 6/10. 5 times 2 is 10. 3 times 2 is 6. This one is a scaled copy because they're equivalent ratios. And so I can keep going. I do 7.5 over 5 is equal to 15 over 10. 5 times 2 is 10. 7.5 times 2 is 15. As a result, these are scaled copies. Boom. I can do my work now on this side here. So we're on to 8 inches by 3.5. Well, 3.5 over 5. Is that equivalent to what am I doing? 8 over 3.5. So is that equivalent to 8 over 10? Well, 5 times 2 is 10. Is 3.5 times 2 8? No, 3.5 times 2 is 7. So we know that this one is not an answer. And then our last one's pretty straightforward, right? 5 times 2 is 10. 10 times 2 is 20. So that one is a scaled copy. Boom. So this question was a little hard, right? Well, it wasn't hard. It was more like tedious. All you're doing is you're testing the ratios of all your answers to see whether or not they're a scaled copy. What might help you is to draw these out, but whatever you guys decide to do will be fine. Now for question number 3, this is saying to scale the image below by a scale factor of 1/3. So we know that we're going to have to multiply all these side lengths by 1/3. Our first step is that we need to count. So 1, 2, 3. Count here, it's 6. Count here, it's 3. And all we're doing is we're filling out each of the side lengths. And then finally, we have to do 1/3 times these. So 9 times 1/3 ends up being 9 over 1 times 1/3, which is 9 over 3. 9 divided by 3 is 3. Bam. Here, I can do, again, 3 times 1/3, 3 over 1, which is just 3 over 3. 3 divided by 3 is equal to 1. Then finally, our last number, 6 times 1/3, 6 over 1. This becomes 6 over 3, which just equals 2. And so now I can draw these out. 9 times 1/3 is 3. So I make a side length of 3. 6 times 1/3 is 2. So I make a side length of 2. 3 times 1/3 is 1. So I make a side length of 1. 3 times 1/3 is 1. So a side length of 1. 6 times 1/3 is 2. Side length of 2. Then 1/3 of 3 is 1. And then bam, we have our answer. Right? And that's all you had to do to go from your original to your scaled copy is you get the side lengths and then just multiply by 1/3. All right, let's go to the next one. This one looks scary, but it's really just some tedious work. And so here it says, here's a scaled map of Lafayette Square, a rectangular garden north of the White House. It's measured 8 inches by 12 inches, right? And it's saying that the actual garden is 456 yards wide. It's asking what is the area of the actual garden? So what we need to do here first is let's get our scale factor. That should be step 1. And so again, this is our width, right? And so what we need to figure out is what do we multiply this by to get to our actual garden. So here we know that this is 456 yards, right? And so we need to figure out, right, 8 times some number, which is our scale factor, is equal to 456. So basically what here we need to do is long division. To get this, I'm going to be doing 456 divided by 8. Let me go from there. 8 can't go into 4, but 8 can go into 45. 8 goes into 45 5 times. 5 times 8 is 40. 45 minus 40 is 5. Carry down my 6. 8 goes into 56 7 times. So our answer there is 57. So that means 8 times 57 is 456. And so that means to get this piece here, I'm going to need to do 12 times my scale factor, which is 57. So I do 12 times 57, right? And so I can do that on the side here, 57 times 12. 2 times 7 is 14. So I regroup my 1. 2 times 5 is 10, plus 1 is 11. I'm now done with the 2, so I move over to the tens place. So I put a placeholder. 1 times 7 is 7. 1 times 5 is 5. And now I can add them up. 4 plus 0 is 4. 1 plus 7 is 8. 1 plus 6 is 6. So that means this is 684 yards. Boom. But this problem is asking us for our area, right? So we need to find what the area of the actual garden is. And we know area is length times width. And so I'm going to have to do 684 times 456 to get yards squared for the area. And so I set this up. 684 times 456. This question is going to be multiple choice. So if you mess up multiplication here, just go to the number that's closest to it. So 6 times 4 is 24. Regroup the 2. 6 times 8 is 48. Plus 2 is 50. Regroup the 5. 6 times 6 is 36. Plus 5 is 41. Boom. So we're done with the 6, and we move over to the 5. 5 times 4 is 20. Regroup the 2. 5 times 8 is 40. Plus 2 is 42. 4 times 6 is 24. Plus 4 is 28. So we're done there. Now we did 6 and we did the 50. Now we're going to move over to 400 to show that we do 2 placeholders there. 4 times 4 is 16. Regroup the 1. 4 times 8 is 32. Plus 1 is 33. Regroup the 3. 4 times 2 is 24. Plus 3 is 27. And I just realized I did something wrong here. I think I did 4 times 6 earlier. It should have been 5 times 6, which is 30. And I ended up regrouping a 4, so 34. Sorry about that. See, even I messed up my multiplication there. But I was able to recognize it, obviously. And then we add them up. So we bring our 4, 0. 1 plus 2 is 3, plus 6 is 9. 4 plus 4 is 8, plus 3 is 11. 3 plus 7 is 10, plus 1 is 1. Regroup my 1. Boom. So the answer here is 311,904 yards squared. So like I said, it's not difficult. It's just tedious for this one. So to recap, we found our scale factor by figuring out, right, 456 divided by 8 is 57, which means we did 57 times 8 to get to 456. Right? And then here, 12 times 57 is 684. So I did 57 times 12 to get 684. So we got our width and length, or our length and width. And then we did length times height to get our area of 311,904. Bam. All right. Next up is we have question 5. So a blueprint of a park uses a scale of 5 inches to 8 feet. This is important. It says if the scaled length of the park is drawn to be 20 inches, what's the actual length of the park? Well, let's find our scale factor. So we know our scale is 5 inches by 8 feet. And so we can get 2 scale factors here, right? We know one scale factor is just going to be 5 over 8. And so that'll be 5 over 8. Or we can do the reciprocal of 8 over 5. 5 over 8 is a fraction. And since 5 is less than 8, we know this is less than 1. So this would make us get smaller. And then finally, 8 over 5 is an improper fraction, which means it's bigger than 1. As a result, we're going to get bigger. Boom. And so here, this says if the scale length of a park is drawn to be 20 inches, what is the actual length of the park? So we're going from a drawing to real life. So if we're going from a drawing to real life, are we getting bigger or smaller? The answer in this case is we're getting bigger. So we're just doing 20 times 8 over 5, right? And we multiply across. 20 times 8 is 160. 1 times 5 is 5. And now we're just going to do 160 divided by 5 to get how many feet the actual length would be. Well, 5 goes into 1 0 times, but 5 can go into 16 3 times. 3 times 5 is 15. 16 minus 15 is 1. Bring down our 0. 5 goes into 10 2 times. Boom. That means our actual scaled length is 32 feet. And now for this question, this says, if the actual width of a swing set at a park is 20 feet, how wide is the scaled width of the park? Well, again, we're going to go from the actual to a drawing. So if we're going from real life to a drawing, we're going to get smaller. And so I do 20 times 5 over 8, right? Because we got our scale factor. So I do 20 over 1. 20 times 5 is 100. 1 times 8 is 8. Boom. And now I can simplify this, right? 8 and 100 are both divisible by 4, so I can simplify it by 4. 100 divided by 4 is 25. 8 divided by 4 is 2. Boom. And so we can say that our, oh, not feet, wow. We can say that our scaled width of the park would be 25 over 2 inches. But if you want to go above and beyond, you can also say that, right, 2 goes into 2 one time. Carry down our 5. 2 goes into 5 2 times. We can say that this is also 12 in 1/2 inches. Or you could have went the division even further to get that this goes in, 2 goes into 10 5 times. And your answer could have also been 12.5 inches. All of these would have been perfect. And again, though, if you guys write it like this, I need to give you guys credit. And if I don't ask you to simplify and you just said it was 100 over 8 inches, I would also have to mark you correct because MCAS would mark that correct. So now we can go on to our next question. Bam. This question is worth the most on your test, but it's also actually, in my opinion, the easiest. So this says Miguel's living room is a rectangle with a length of 6 meters and a width of 4 meters. This says to draw and label a scale drawing of Miguel's living room using a scale of 1 to 100. So our scale is 1 to 100, meaning, right, I can write scale here. Say it's 1 to 100. And again, our scale factor, I have 2 of them. I have 1 over 100, or I can do 100 over 1. 1 over 100 is a fraction, so we're going to get smaller. And then 100 over 1 means we're going to get bigger, right? Because it's greater than 1. Here, this says draw and label Miguel's living room using a scale, right? His actual living room is 6 meters by 4 meters. So that means we're going to go from the real life living room to a drawing, we're going to get smaller. So I'm going to multiply by 1 over 100. So again, I do my 6 meters times 1 over 100, which just gives me 6 over 100 meters. Boom. And then I would do 4 meters times 1 over 100 again. And then this would give me 4 over 100 meters. And so if I draw this out, this would be 4 over 100 meters. And then this would be 6 over 100 meters. Bam. And that's it. And so then this one says, what are the dimensions of your scale in centimeters? Well, in 1 meter, there's 100 centimeters, meaning I can just multiply these by 100. So 4 over 100 meters times 100 centimeters, right? This would give us 400 over 100, which just equals 4 centimeters. And then 6 over 100 meters times 100 centimeters over 1 would give us 600 over 100, which is just 6 centimeters. So we can say the scaled length and width would be 6 centimeters by 4 centimeters. Boom. And so now, right, we can now talk about part C. So in part C, this says Miguel's sofa measures 5 centimeters by 2 meters. What is the actual measurements of his sofa? In meters, that's important. Well, we know our scale is still 1 to 100. Boom. So going from a scaled measurement to real life measurements, are we getting bigger or smaller? We're going to get bigger. So that means we're going to multiply it by 100. So 5 times 100, 2 times 100 gives us 500 centimeters and 200 centimeters. Bam. But it's asking us to get our answer in meters. And we already said that there's 100 centimeters in 1 meter. So that just means that 500 centimeters, right, divided by 100 gives us 5 meters. And then this one would be 200 centimeters divided by 100, which is just 2 meters. And so if I was to draw this out, if you guys drew this out as 200 centimeters by 500 centimeters, that's okay. That's just the measurements that you guys got here. But if I wanted to draw it in meters, again, we divide it by 100. This would be 2 meters. That would be 5 meters. Bada bang. And that's all this question wanted. So we would say it's 5 meters by 2 meters. Boom. And now we're going to move on to our last question here, where here it says, here's a scale drawing of a playground. Boom. The scale is 1 centimeter to 30 meters to get this. This says to make another scale drawing the same playground at a scale of 1 centimeter to 20 meters. Well, if I was to do this, right, if I'm going from 1 centimeter to 30, and I change the scale to 1 to 20, to make this easy, we can make a ratio of this to be 30 over 20, which is just 3 over 2. And so that means if we decrease our scale, this image is going to get bigger, and it's going to get bigger by a factor of 3 over 2. And so if I wanted to first off draw this out to label it, this side length would be 5 times 3 over 2. So I can do that here. Boom. So this would be 15 over 2 meters. So I can put 15 over 2 meters here. Boom. Again, this side length would be 7 times 3 over 2, which would be 21 over 2 meters. So I can put this as 21 over 2 meters. Boom. Here would be 10 times 3 over 2, which would just be 30 over 2. 30 divided by 2 is 15. So I can say that this is 15 meters. And then finally, 5 times 3 over 2 would give me 15 over 2 meters. So I can say that this is 15 over 2 meters. And that's all you had to do, right? And so how do the two scale drawings compare? We can say the second scale drawing is bigger. And that's because we went from a scale of 1 to 30 to a scale of 1 to 20. And that was our study guide. I hope that helped y'all. Appreciate y'all.